So in this table here, we have two different communities, community 1 and community 2, and each of them contain 3 different species. And we see the populations of those 3 different species. And we also see that the total populations of each of those communities is the same. They both have a total of 1,000 individuals. Now my question to you, just intuitively, based on the data in this table, which community would you say is more diverse and why? Community 1 or community 2? All right, now let's think about this together. So as we already talked about, they have the same number of individuals, and they actually have the same number of species. Both communities contain species A, species B, and species C. But when we look at the data, it's clear that community 2 is mostly species A, and you have very small groups of species B and species C, while community 1 is more evenly spread. So just intuitively, it feels like community 1 is maybe more diverse. But this was just on my intuition or our intuition, and the numbers are pretty clear here. It's evenly distributed amongst the species here, and here it's very heavily weighted on species 1. But it might not always be this clear. So it'd be useful to have some type of quantitative way to measure the diversity of a population. And lucky for us, there is a quantitative way to do that. You could imagine different ways of doing that, but the one that's most typically used in biology is called Simpson's, I'll write it down, Simpson's diversity index. And the way you calculate it, it's equal to 1 minus the sum of, for each each species, you take the number of that species in the population, divided by the entire population size, squared. So for each of the species, you do this calculation, the number of that species divided by the total number in the population, square it, and then you add it up for each of those species. So let's figure out Simpson's diversity index for both communities 1 and community 2. And I encourage you, you could pause the video and try to work on it on your own before I work through it with you. So let's start with community 1. So I'll say diversity index for community 1, I'll just put that in parentheses, is going to be equal to 1 minus, so we have 325 over the total population over 1,000 squared. Remember, we're going to sum on each of these species, plus 305 over 1,000 squared, plus 370 over 1,000 squared. And I need to close my parentheses. And I can simplify this a little bit. This is going to be equal to 1 minus, so all of these 1,000 squareds, 1,000 squared is 1,000,000. So it's going to be everything over 1,000,000. 1,000,000. And then we're going to have 325 squared plus 305 squared plus 370 squared. And that is going to give us 325 squared plus 305 squared plus 370 squared is equal to that. That's the numerator here. Now I'm going to divide that by a million. Divided by 1, 2, 3, 1, 2, 3. That is 1,000,000. It equals this. And then I'm going to subtract that from 1. So I'll just put a negative sign here and say plus 1 is equal to 0.664. So this is going to be approximately equal to 0.664. Now let's do the same thing for community 2. So if I write it over here, the diversity index for community 2 is going to be equal to 1 minus, I'll put a big parentheses here, and we're going to have 925 over 1,000 squared plus 40 over 1,000 squared plus 35 over 1,000 squared. And if we simplify in a similar way, that's going to be equal to 1 minus all these 1,000 squares, that's just 1,000,000. And that's a common denominator. And so you're going to have 925 squared plus 40 squared plus 35 squared. And then this is going to be approximately equal to 925 squared plus 40 squared plus 35 squared is equal to this. Divide it by a million. So divided by 1, 2, 3, 1, 2, 3, yep, 6 zeros is equal to that. And then you subtract that from 1, and you get, which is approximately equal to 0.142. And so we see very clearly when we use Simpson's diversity index that, consistent with our intuition, community 2 has a lower diversity index than community 1. And it's consistent with our intuition that it is less diverse. And I encourage you after this video, think about why that makes mathematical sense.